This is our second day of 6.6. We're going to continue solving exponential equations and also logarithmic equations. So an exponential equation, just like our last lesson, we have 2 to the x equals 7. But the problem is now I can't rewrite 7 as a power of, as a base of 2 to a power. So I can't solve this the same way I did before. So instead what I'm going to do is I'm going to turn this into a log. So this is log base 2 of 7 equals x. And now I know I can solve this just using the change of base formula. Log 7 over log 2. And if I were to put that in the calculator, I would get 2.807. So if we have exponential equations that we can't easily solve, we can solve them by turning them into logs. So you try both of these, pause when you're ready to see the answer, hit play. So for the first one, 3 to the x equals 8 turns into log base 3 of 8. So that's log 8 over log 3, and I get x is 1.893. For number 2, I have log base 6 of 100 equals x. So that's log 100 over log 6, and I get x equals 2.570. So here we have the property of equality for logarithmic equations. So if I have two logs, both with the same base, then I can set those parts equal. So log base 2 of x equals log base 2 of 7. That means x has to be 7. So in part A, I have the natural log of 5x plus 2 equals the natural log of x plus 10. So I can take 5x plus 2 and equal it to x plus 10. So that's going to be 4x equals 8 divided by 4, x equals 2. For the second one, I have log 7x minus 2 equals log 4x plus 10. Both common logs, so we have 7x minus 2 equals 4x plus 10. So that's 3x equals 12, x equals 4. So you try the next two, pause, when you're ready to see the answer, hit play. So in number 3, we have 12x plus 1 equals 5x plus 57. When we solve, we get x is 8. For number 4, we have 2x plus 26 equals 4x minus 2. We get x is 14. There will be some logarithmic equations, though, that do not have the log on both sides. The log is only on one side. So I'm actually going to do the opposite of what I did with the first problems, where I took an exponential and turned it into the log. I'm now going to take the log and turn it into an exponential. So remember, around, so we have 3 to the 4 equals 10x minus 9. And I can actually evaluate 3 to the 4th power, so that's 81 equals 10x minus 9. And now this is just a regular equation. So we'll add our 9, divide by 10, and x is 9. All right, here we have 5 to the 3rd equals 3x minus 7. So that's 125 equals 3x minus 7. 3x is 132, and x is 44. So you go ahead and try this one, pause when you're ready to see the answer, hit play. So we get 2 to the 5th equals x minus 6, or 32 equals x minus 6, and we get x is 38. So some logarithmic equations will still have multiple logs in them, but they're all on one side of the equation. So what we're going to do is we're going to condense it first before we solve. So on this one, we have log base 4 of x plus 12 plus log base 4 of x equals 3. So we know the plus really means multiplication. So this is log base 4, I'm going to put this x first, x times x plus 12 equals 3. And now I could still do 4 to the 3rd power equals x times x plus 12. 4 to the third is really 64. And here, x times x plus 12 is x squared plus 12x. And this is a quadratic, so I'm going to subtract 64. And I'm going to solve this by factoring. So I'm looking for what multiplies to negative 64 and adds to positive 12. That's x plus 16 and x minus 4. We're going to have x equals negative 16 and x equals 4. And we're not going to take the log of any negative number, so this is out. So our only answer here is x equals 4, right? X equals negative 16 was extraneous. All right, let's do the same thing for the next one. So this is, again, multiplication, 5x times x minus 1. So this is log 5x times x minus 1 equals 2. A common log, remember, really has an invisible base of 10. So I could say this is 10 squared equals 5x times x minus 1. So we have 100 equals 5x squared minus 5x. Subtract the 100. And I could actually divide everything here by 5, right? Divide both sides by 5. So now I have 0 equals x squared minus x minus 20. So the two things that multiply to negative 20 add to negative 1 are x minus 5, x plus 4, which means x is positive 5 and x is negative 4. Negatives out, x equals positive 5. So you go ahead and try the last problem. Pause. When you're ready to see the answer, hit play. So for our last problem, we end up with log base 6 of 6x times x minus 1 equals 2. So 6 squared is equal to that 6x times x minus 1. We end up with a quadratic of x squared minus x minus 6 equals 0. And we get a solution of x equals 3 with an extraneous solution of x equals negative 2. And that is the rest of solving exponential and logarithmic equations.